We're Group 6, Section C, and we are in charge of designing the engine, the seat, and the steering for the Mario Kart. I was in charge of designing the engine internals, which include the crankshaft, the camshaft, the valves, the pistons, and the piston rods. All the internal parts were fabricated from steel because of the high temperature environments. The pistons are designed to be relatively large in order to maximize the power output of the engine. And the crankshaft and piston rods are designed to have a very long stroke, where the overall distance the cylinder moves up and down in one cycle of the engine.
I was in charge of the engine exterior. The engine exterior are the engine oil pan, engine block, engine head, engine valve cover, and the engine cooling fan. Everything except for the fan is made from aluminum for its lightweight and durable properties. The fan is made from a lightweight but high temperature plastic. Weight in an F1 car is crucial in order to achieve an acceleration at its maximum peak. The engine exterior was designed to all bolt together as shown in order for easy repairability for the parts inside.
I was in charge of the seat and the harness. The seat is designed for ergonomics and based primarily on the design of an F1 style car. There's an integrated 5-point harness to ensure the safety of the driver. The seat is designed to be positioned so that it's tilted backwards in order to reduce the overall aerodynamic drag, yet to maintain the driver's line of sight. The seat is made of lightweight plastic material to reduce weight and cost. The safety harness straps are made of nylon, and the buckle is made of steel to make the harness as strong as possible.
I was in charge of designing the upper steering. The upper steering consists of the steering wheel, steering shaft, shaft housing, and the pinion gear. The steering wheel is designed for the driver's comfort and is modeled after a Formula One style steering wheel to improve the driver's experience. The steering shaft and steering shaft housing that connects the steering wheel to the steering rack are made from aluminum 6061, which is a lightweight yet extremely strong aluminum alloy used in the aircraft industry. The steering shaft connects to the steering rack, which turns the wheels with the pinion gear.
I was in charge of the lower steering, which consists of the rod, rack housing, the back housing plate, and the tie rod ends. The lower steering components are also fabricated from aluminum 6061 for, again, its lightweight and durability. The steering geometry was altered to allow for a tighter turning radius. Essentially, the outside wheel turns at a larger radius than the inside wheel to allow this increase in turning radius of the car.
Hi, I'm Jesse Simpson. I worked on the wheels and tires for the car as well as the brake rotors and spindles. The main component of the wheels and tires are the rims. The tires mount onto the rims and provide traction and allow the car to move. The rims are a stylish feature to the car and allow the car's owner to express himself and show other people a little part of himself. Basically, they're a form of self-expression. The rotors are an integral part of the brake system which allow the car to stop quickly and safely. Without them, the car would never stop and the driver would be placed in extreme danger. The spindles act as a block that sits between the control arms, allowing them to compress to absorb bumps in the road and therefore are a very important part of the suspension. The brakes are what the wheels and brake rotors rotate on and need to be very strong and well designed to prevent them from melting and destroying the car and its owner.
My name is Matt Myers and I worked on the braking system for the car. The main component of the braking system is the brake caliper. The brake caliper uses 4 pistons to squeeze a pair of brake pads into the brake rotor, which ultimately slows the car. This added braking power ensures safety and improves performance of the Mario Kart. I also designed the main rear axle and bearings within the wheel assembly.
Hi, my name is Adi and I focused on 2 major components of the kart, the suspension and the drivetrain. The previous group did not have a functioning suspension. I redesigned our suspension based on a Formula One style pushrod suspension. The advantage of this design is that the components are collapsed to allow airflow through the side scoops. Also, the design produces more downforce through turns to provide better handling. The rear suspension was also redesigned to a simple compression setup. The only major components are control arms to keep the wheels attached to the chassis and rear coil springs to provide constant downforce to the back wheels. Since our car is rear-wheel drive, the downforce on the back wheels is necessary. The previous group did not have a functioning transmission, which is not conducive to racing, as the transmission allows the car to travel at different speeds over the same engine output. In connection with the clutch, I designed a 5-speed gearbox based off the gearbox of a 1986 Porsche 911 Carrera RS, because our car has a similar power-to-weight ratio and weight distribution characteristics as that model of the Porsche 911. On the next screen you can see the gear ratios.
Hi, I'm Ryan Stroh, and the car we modified had virtually no working transmission, so it was crucial for us to create a design that allowed the car to function. To begin, we started with the basics of creating a transmission by designing a clutch, a gearbox, and a differential. I designed the differential, which is where the gears for the transmission connect to the rear axle and drive shaft that turn to allow the car to move. Secondly, I planned the gearbox, which contains the clutch and connection to the gear shifter.
Hi, my name is Jin Hyuk Kim. I worked on creating the clutch of the car. The clutch design is what allows the driver of the car to switch between gears when driving. I created parts that connect to the differential gear as well. I worked with Ryan and created the parts that connect between the differential and the transmission. The output shaft had to be connected to the differential by some type of connection to transfer rotation. I designed the pins, connectors, and gears so that the transmission and differential could work.
I'm Venkatesh Chinakonda, and Section M's design centered around speed, aerodynamics, and efficiency. The project started as a go-kart, and we were supplied the task of improving design. We thought that one of the best ways to improve the design would be implementing changes to the body design. Because we were creating an F1 car, we had to modify the body parts. We also implemented new parts to maximize the power of the engine and enable the car to be the best that it could on the track.
Hi there, I'm Trent Keatman. One part I designed was the front wing of the F1 car. The go-kart designs we were supplied with had a front wing that would not fit on the car and was not sufficient to limit air drag. The new design used smooth edges with a sharp front made of carbon fiber to best push air past the car and make it aerodynamically sound while also being lightweight. Another part I designed was the air scoop. The previous go-kart didn't have an air scoop, so this part was created from scratch. It was designed to look and function like an air scoop that would be seen on a typical F1 car. The air scoop is designed to take in passing cool air and supply it to the engine to lower its temperature and increase the power of the engine. Finally, I modified the chassis of the car. It was modified to have a sleeker, more aerodynamically sound body that resembled a typical F1 car. The chassis was important in that it houses all the other parts of the car, so dimensioning it just right was essential in order to have all the other parts fit together nicely.
Hello, my name is Christopher Armstrong. I was responsible for designing the rear spoiler, side panels, and the majority of the presentation files. With a similar purpose to the front spoiler, the rear spoiler is designed to keep the go-kart on the ground at high speeds. Like most of the exterior parts, the spoiler is made of carbon fiber to maximize strength and minimize weight. The side panels were designed to aesthetically improve the go-kart as well as decreasing drag and torque on the go-kart. Being also made of durable and lightweight carbon fiber, these side panels also provide the important role of providing airflow to the engine parts. Finally, I was responsible for creating many of the explosion parts and drawing files, as well as the animation for this group, to help detail the parts in our assembly and visualize the project as a whole.
Hello, my name is Rehan Khan, and one of the main parts I was responsible for was the air intake. The old design was a box filter which consumes much less air than the cone filter. I redesigned a cold air intake with the cone filter and added a heat shield. The cone filter allows much more air to be filtered through the system, resulting in better fuel consumption for the overall system. The heat shield ensures that the cold air is always cold and the engine does not heat up all the air that's being fueled into the system. With this new modification, the cart is much more fuel efficient, and on top of it all, it adds a little more power to the system. Another part I redesigned was the straight pipe exhaust, which was an upgrade from the old bent exhaust. The bends in the previous exhaust made it much more restrictive, and the airflow did not flow directly straight out to the muffler. The muffler goes at the end of the exhaust, which results in less harmful emissions into the air. Altogether, the cold air intake combined with the straight pipe exhaust makes the cart much more fuel efficient and adds a lot more power to the overall system.
One of the first modifications I designed for the car was the turbocharger system. This included the turbo and its piping system. The addition of the turbo provided the engine with more power through forced induction rather than a naturally aspirated engine. Once Section D was done with their suspension assembly, I worked on assembling the rest of the car by constraining the body panel, seat, and the drivetrain to the chassis. The toughest part of this stage of the project was adjusting the parts to fit the chassis, since some parts were not in proportion to the rest of the car. However, once I finished tweaking the parts, we ended up with a very sleek and well-designed Formula One car.